Hi, welcome to Chapter 15. I'm Professor Waits, and in this chapter, we're going to talk about inheritance, polymorphism, and virtual functions. I do want to let you know that this chapter might be a little bit more complicated than you are used to, and that is mainly because in this, we're going to talk about a lot of object-oriented terminology, concepts, some theory. And you got to get to know these pieces when it comes to object orientation. It's why we do object orientation. And while it's sometimes difficult to wrap the brain around it, what I find is, for at least for me and for other people I've talked to, it's kind of this nebulous idea until all of a sudden it just kind of snaps. So you may have to watch these videos several times to get some understanding. And I will actually keep the videos somewhat short so that way it's a little easier to go back and check on these videos. So why do we have inheritance and what is it? I want you to take a moment and imagine something like a car. A car and another car have a lot of similarities, a lot of things that are almost exactly the same, if not exactly the same. Do you want, when you're sitting down to write out the blueprints for a car, do you want to sit down and write the blueprints for every single car and essentially duplicate your efforts every single time you write out a new car? Or would it be nice to be able to set up one blueprint that says, hey, this blueprint is the common option. It's the piece that most cars are going to share. And so we want this to be kind of the base diagram for what a car is. And then from there, we'll make other little diagrams that explain the very specific thing. So that's what inheritance is. What we can do is we can create a class that is and remember, class is a fancy word for template. We're creating a template for an object. We can create a class that has these similar parts for all kinds of objects, and then create more classes that utilize that blueprint to go ahead and create more objects that are specialized. So let's take a look at that kind of that concept. So here's another example where we have insects. All insects have certain characteristics. But then we want to get a little bit more detailed. And so we say, in addition to the common insect characteristics, the grasshopper has its own unique characteristics, such as the ability to jump. And with bee, it also is unique and has such abilities to sting. But yet, they do share a lot of commonalities with insect. This is where inheritance comes in. We start to create what's known as a is-a relationship. So with inheritance, we establish this is-a relationship, and you'll see that to the left of the is-a is a much more detailed version of what's on the right. A poodle is a dog. A car is a vehicle. And this is interesting because we were actually breaking this down even more. We could have said a Ford Fiesta is a car. So we have a flower is a plant, and a football player is an athlete. So now that we've talked about inheritance, let's talk about some of that terminology notation. That base class, which is that top item, this insect, we call that the base class or the parent. And you're going to inherit from this base class. Now with that, we have derived classes or the children classes. And these are the classes that make use of the base class. So here we have a class student, which is great. It's a very kind of upper parent kind of object, or template, I should say. So we have a class of a student. Well, what kind of student? We have an undergrad. And again, as a grad student and an undergrad student, they share a lot of similarities like grades, attendance, GPA, but student and an undergrad versus a grad student have some differences, and we can define those differences within the undergrad class or the grad class. But see how we have this colon here and then the public student? This is how we say that we want to extend from the base class student. Now, you're probably saying, okay, Professor Waits, how do I know that this is a base class? What signifies it as the base class? Well, there's nothing that really signifies it as a base class. And in fact, if you didn't know the entire application, you may not know that this is a base class because you actually have to find the derived classes. That's where you're going to see a class being a parent. And interestingly enough, you can have this class called student, and that is extended to the undergrad. And believe it or not, you can actually have undergrad as a parent too, and some other object extend from the undergrad class. So again, we don't know what that class is right now, but let's just say we did. And so now we've got this class here that extends from undergrad, that extends from student. We'll talk a little bit more down the road on what that means. All right, so back to the is a relationship. So when you have a derived class, it's an is an object of the base class. So an undergrad is a student. A mammal is an animal. Or to our example before, we're just saying that grad is a student. So what does a child have? Well, when you have a derived class, all the members defined in the child class and all the members declared in the parent class. So yes, all the members declared in the parent class also can be used by the child class. So an object of derived class can use all public members defined in the child class and all public members defined in the parent class. They are purposely saying public. Protected members and class access. So, and the reason why I was saying that they're purposely mentioning public is because of what we're about to talk about now. So protected members and class access. Now, a protected member access specification, it's like a private, but it's accessible by objects of derived classes. Whew. Okay. So that's the important piece here. Private cannot be accessed by the child class, but protected can. So remember that. Protected member access specification is like a private, but it is accessible by the objects of derived classes. Class access specifiers. Well, we've talked about public, and that's an object of derived class can be treated as an object of the base class, not vice versa, right? So that's really important to understand is, so if you have your parent class, ooh, yeah, not using my pens today, you have to forgive me. And then this is a child. If this has a method, let's say A, and this has a method, let's say B, well, if this is a public A and a public B, your parent class has access to A, but not to B. However, with the child class, because it's deriving from this class, it has access to both B and A. Now, protected, more restrictive than public, but allows derived classes to know details of parents. So again, if we have a method up here, let's say method C, then the child class here, or the derived class, because this is protected, can still see C. However, outside classes cannot see C. We shouldn't even draw a line there because we're not trying to insinuate that these are connected. We're just trying to say that this class over here, this unassuming class, cannot see C because this is protected. And then private prevents objects of derived classes. So if we had another method up here, D marked private, then even C, the child cannot see it. So keep that in mind. Public, everybody; protected, only derived; and private, nobody can see it. So this kind of goes a little bit more into what we were just trying to draw. And so this is a little bit nicer of what we're seeing. Now remember, on the one side over here, this side is all base classes. And these are all of the derived classes. So we know that because X is private, only the base class can see it. Now protected, Y can see it, and it comes across in Y as a private item. And then same thing with Z. Z can be seen by the derived class. Now, what this doesn't show is if you have some other class or some other piece of code, we've already said that that code can see Z as well. However, because this is protected, it cannot see Y. All right. Now you might be going, wait a second, Professor Waits. All of these are the same on this side, but they're not the same on this side. And that's because of this access. So when we use these different accesses, it does modify how it shows up in the derived class. So because we're using private here, protected is always going to be private, and public is going to be private inside that class. If we're using protected, then we always still know that X is not viewable, but protected will stay protected, and public will now become protected. And then finally, if we use public, it pretty much leaves everything alone. Again, we can't see private, but protected is going to be protected, and public is going to be public. So here we got more inheritance versus access. Again, we've got this class grade, and here are private members and our public members. And over here, we have this class test that is extending from a public grade, which means that we are automatically, when the test class inherits from grade class using the public class accessor. And where's that accessor, you may be saying? Well, it's right here when we declare it as a public. That's the access. Versus the fact that these are private inside the base class, these are protectors. All right, so in this case, we're going to say, since these are private, letter, score, calc, and we have public, that means we don't have access to any of those. But because set score and get letter are all there, we get all of those. And we also get the one we in this class are declaring. Now, in this example, let's not go too high. Now we're using protected. Oh, well, hey. Again, we already know that private of the base will not show up down here because they're not there. We can't get access to them. We have access to our own, and so that's why these are right here. And then what happens to public when you use the protected access? Well, it should make all the publics not protected. And so here you go. But then we finally have our public method that we created for this class, and it's going to stay the same. Then finally, this is with the private. So here's the private. Everything's going to turn private. So we've got this. It's going to be private. Uh, However, and let me rephrase that. Because this is public within the derived class, as in we declared it in the child class on its own, it's going to remain what it is, which is public. But the rest of these public items from the base class will come in and be a part of the privates. All right, we're going to stop here. I want you to take a moment and try to digest all that. I know I just threw a bunch at you and understand. And then we're going to talk about constructors and deconstructors between the base and derived classes. Thank you so much, and I look forward to seeing you soon.